Hello, my name's George, and today I'm going to talk about how we can use NPM packages outside of Node. NPM has lots of useful JavaScript packages. Many of them can be used both within Node.js and on other platforms like Vercel Edge Functions, Cloudflare Workers, or with the help of a bundler like ESBuild or Webpack in web browsers. But some packages assume the presence of Node-specific features like buffer or built-in Node libraries like fs, path, or net. These packages can't so easily be run elsewhere. And that shouldn't be a big surprise. NPM is the Node package manager after all, but it can be an annoying roadblock to some things we might want to do. And this is a problem that we faced at Neon. We wanted to make Postgres usable from serverless platforms like Vercel Edge Functions and Cloudflare Workers, but the existing Postgres driver packages all made use of Node-specific features. Some platforms make an effort to help you with this. For example, on Cloudflare Workers, you can add a setting node compat equals true to your Wrangler TOML file, and that makes some effort to provide Node-specific functionality. But this doesn't fix every issue, and it's not available everywhere. So in this talk, I'll describe some ways that you can fix this problem for yourself. In other words, how to use NPM packages outside Node.js. There are 5 related techniques, all using examples from the development of Neon's serverless driver, which is adapted from the Node Postgres PG package. All the solutions that we'll cover today have one thing in common, which is that they all use one of my favourite tools, ESBuild, to combine your JS files and dependencies into a single runnable bundle. And if you'd like to refer back to these techniques after the talk, I've also written them up in a blog post at this link. Secondly, today we'll see some of these techniques in action. So what we'll do is set up a Vercel Edge function to use the query builder package connects.js to communicate with a Postgres database. And that doesn't work out of the box, so we'll proceed to fix it using some of the techniques that I will by then have shown. So technique number 1. Probably the simplest case we'll come across is where a package uses Node-specific features that have to be especially imported or required, and there's already an equivalent third-party shim library available. In our serverless driver, events, which provides the event emitter object, falls into that category, for example. Now in this case, all we have to do is npm install the package. So npm install events, for example. And that third-party package then gets used instead of the built-in Node package that was originally intended, anytime that the events package is referenced via a require or import. And the final thing that we then need to do is bundle the code using ESBuild. And when we do that, this third-party event support will be included in the bundle. Almost as simple is the situation where a package relies on a global Node object, for example, buffer, for which, again, there is a third-party shim library available. And in that case, again, we do an npm install. This time, of course, it's npm install buffer, but we also have to make sure that the shimmed object is always available in the global scope. And it turns out actually that ESBuild has a special inject option to support this. So we create a new file, which here I'm going to call shims.js, with the following content. And what we're doing in this 5 lines of JavaScript, firstly, we're checking if there is already a global buffer constructor function, and if there is, then checking whether it has a static alloc unsafe function attached to it. And we need that second test because on some platforms there's a booby-trapped buffer function that exists only to throw a supposedly helpful error message when you try to use it. Now, if both of those checks succeed, which probably means we're running in Node, we simply export the built-in buffer object on the second to last line there. But if either of those checks fails, then instead we require and export the third-party buffer object instead. Finally, to make sure that this buffer object is present in the global scope for all of the code that we're bundling, we add the inject switch to our ESBuild command, which looks like this. You can see we've added there -- inject and then the name of the file that's going to be injected. We use this same trick to provide our own shims for some other Node built-ins. For example, shims.js in our serverless driver also contains an implementation for Node's process next stick. And the implementation in our shims.js looks like this. And again here, firstly, we're creating a global process object if there isn't already one available. Then we check whether calling process nextTick throws an error. And if that does throw an error, it could either be because nextTick doesn't exist, or because nextTick is one of these booby-trap functions provided by the platform that again just raises an error when we call it. And if it throws anyway for either of those reasons, we attach our own nextTick implementation to the process object. And we do that using a resolved promise, which is about as close as we can get to Node's native nextTick on other platforms. Another common issue is that a package imports a Node.js built-in library that actually isn't really needed. For example, the PG package depends on the pgparse package to read passwords from a .pgparse file in your home directory. And most of the time, and certainly in a serverless environment, almost all of the time, you're not going to need that functionality. But because the pgparse package tries to import the file system package, fs, to read that file, that makes bundling fail if the fs package isn't available, whether or not you're ever going to use that feature. Now, one option here would be to use ESBuild's external option in this situation. And that option would tell ESBuild not to try to bundle that particular package, and instead to leave a require or import statement in the bundled code. That might work in this case, but depending on how the require or import statements appear in the bundled source code, some cloud platforms will throw errors at upload time when packages that are referenced that way turn out not to be available. So instead, for maximum portability, you can create an empty or stub fs package. And that package could be fully empty, or it could implement some stub functions that throw informative errors if we ever accidentally call them. So a stub package consists of a folder containing just a package.json file and a JavaScript file. For example, in our Neon database serverless package, you'll find a stub fs package in shims fs. And our shims fs package.json file inside that directory looks like this. The key things here are the name and the description. The name has to match the package that we're shimming, and the description may be helpful when people come to look at your code in future. We say that it's a module, and we tell the bundler where to find the entry point with our main key there. And then alongside that, in shims fs, we have a single JavaScript implementation file, and we implement just one stub function stat, which is called early on by pgparse. And all that does is just inform us that we can't stat because there's no file system. So you can choose whether or not you want to include these sorts of stub functions. You will get an error message either way. If you include some stub functions, then you can make the error messages just a little bit more informative. So once you've created a stub package like this, you need to add it as one of the dependencies in your overall package.json file. And we add it as a local path package, one that uses the file URL protocol. And that looks like this. So you can see there the dependencies object in package.json, and we have added our fs shim in there. And once you've done that, finally, you need to run npm install, and that will copy our shim package inside the Node modules folder, where it can be picked up and bundled when we rerun the ESBuild command. Now we can use essentially the same technique when a package imports a built-in package and really does need to use it, or at least needs to use some part of it. Happily, it can often be quite straightforward to re-implement or translate functionality in that case. A couple of examples, again drawn from bundling PG as Neon's serverless driver, are string decoder and URL parse. If we take string decoder, it's very straightforward to re-implement this using the text decoder object that's available in browsers and on serverless platforms. So we create a string decoder folder, and inside it we again create a very simple package.json file. Only the name and description have changed here from the previous shim package that we looked at. The name again needs to match the package that we want to shim. And then in the index.js file, so in the JavaScript implementation, the implementation of string decoder is super simple. It just translates string decoder methods to text decoder methods. So at the point that the string decoder is constructed, we just create a text decoder object for use behind the scenes, and then both write and end on string decoder make use of the text decoder's decode method, with or without the streaming option, depending on which one was called. And certainly for the purposes of this example, that's a perfectly sufficient implementation of string decoder. Just like in Technique 4a, it's important not to forget to add the shim package to your overall package.json file. As we can see here, we've added string decoder to the dependencies there. And again, then to run npm install so that the package is copied to the Node modules folder. Of course, sometimes you need to use a package that isn't so simple to shim. It could in fact be the whole purpose of the package that you're writing. For instance, the reason that our serverless driver package exists at all is to let you communicate with Postgres even where TCP connections over net.socket are not available. And we make that happen by re-implementing key parts of net.socket using WebSockets as the underlying transport. The principle is just the same one that we saw in Technique 4b just now. It's just that the implementation file is longer. And if you're curious, you can find the implementation file that we use in our driver at this address on GitHub. The last trick I'll discuss today is again a very closely related one, and it allows you to substitute one package for another in a third-party package's dependencies. And I've used this to make my Zapatos package, a TypeScript Postgres library which normally depends on PG, depend on the Neon serverless driver instead. And to make this work, we create a local path package, same as in most of the previous examples, and we name this local path package after the package that we're masquerading as, in this case PG, and in that we simply export the alternative package that we want to be used in its place. So we have this shims PG folder, and inside that we have a package.json file that declares that this is a package called PG, as we can see here. And the pattern here is slightly different to the one that we've seen before, in that I've provided both CommonJS and ESM exports for flexibility in using this shim, and those point respectively to an index.js and an index.mjs file, depending on which one gets used. Those JavaScript files, the JS and MJS ones, are in fact then just one line each. You can see that in the CommonJS index.js file, we just add the serverless driver to the module exports key, and in the ESM file, the .mjs file, we simply export everything from the Neon serverless driver package. And I don't have a slide for it this time, but again, you would need to add this new custom PG package as a local path package to your overall package.json, and again, to run npm install. And you can see this technique in action in an example repo that I've given a link to here, and that's a simple app implemented using Zapatos and Neon's serverless driver on Vercel Edge Functions. So lastly today, I want to do a little bit of a work through. Let's see how that we can apply these techniques in a real task. And the real task that we're going to do is this. We're going to get the query builder package connects.js working on top of Neon's serverless driver within a Vercel Edge function. So let's switch to VS Code now and take a look at the problem here. So this is a really minimal Vercel Edge function that we're looking at in VS Code here. It has a public directory. There's nothing useful in that, but we need a public directory with some kind of file in it just to stop the Vercel CLI tool complaining when we run it. So that exists there. There's an API directory with one JavaScript file in it. That will be our Edge function API endpoint. And that's just everything kind of bundled into a single file using esbuild. And then alongside that, we have this API source directory, and that has the corresponding not yet bundled source file for the API file that we saw above. Now, within this source API file, we do sort of three separate things really. We start out by just importing connects and the Neon driver in those first three lines. Then we set up connects to use the Neon driver, and we do that by subclassing the standard PG connects driver, but returning Neon's driver rather than PG in that driver function. And then thirdly, the main thing that we do is that we handle any web requests by making a simple database query and returning the result as JSON. And note that we also disconnect from the database here to avoid exhausting our database connections if this gets under heavy load. And by using the wait until method in our Vercel Edge function, we're able to do that without holding up the response. So this means that the Edge function won't terminate until the connection has been closed, but the response will be sent before that. If we awaited destroy, then we would make the user wait, but by using wait until, we don't make the user wait. Now, to make this an edge function, we need this magic line where we export a config variable. This has to appear quite similar to how it looks here. If this gets bundled by ESBuild, it may end up in a format that the Vercel Edge function doesn't recognize. So rather than including this in the source, we actually add this exact line at the end of the bundled source as a step in the build process. And we'll see that build process now if we look in the package.json file in this repository. And the package.json file, of course, has our dependencies. So it has the Neon serverless driver and connects their listed as dependencies. And it has the ESBuild build command that we're going to use. Of course, we've got ESBuild as a dev dependency here to make that work. And there are a number of elements to that, but essentially we're asking ESBuild to work on all the JS files in the API source directory, to bundle the files that it encounters there, to put the bundled versions in the API folder. We're asking for the ESM module format. Log limit 0 means that we see all of the logs. 0, in fact, means don't limit the logs at all, so that if there are error messages, we can see all of them. And then, as I mentioned before, we need to add this footer line that makes sure that Vercel treats this as an edge function rather than an old-fashioned serverless function. So what happens when we try and build and run this? Let's open the terminal in VS Code and let's try running npx vercel dev to get a development version up and running. Now I'm expecting that this will create errors because of course there are packages here that are native to Node.js that aren't going to be recognized. Okay, so it's actually telling me that there are 25 errors here, and if we scroll up, I think we'll find that all of these are errors where a particular package can't be resolved. So there's a Node native package and it's not available here. Now, just to sort of boil down those 25 errors into which unique package is not found, we can try and grep for that. So npx vercel dev, and we'll look for that phrase could not resolve, and we will then sort and uniqueify that. Now, the one thing that I haven't done here is I'm grepping here amongst the standard output, but we in fact need to be grepping among the standard errors. So let me redirect that here. And that should now give us a list of the unique packages that it can't find. Yes, and there are 8 of those packages. Okay, assert, crypto, events, fs, stream, timers, tty, and util, all of which are not able to be found here. Now, you might notice that ESBuild has suggested that we add the platform equals node switch to fix this. That won't help us. That will resolve the errors at build time, but since those packages aren't actually available on Vercel Edge Functions, that won't fix the problem. It will just punt it to later on in the process. So 8 packages. Actually, this is not as bad as it looks. Having investigated these a little bit, the 8 break down into 3 categories. The first category are packages that we need, for which there is an implementation already available on NPM. This was technique 1 in the slides that we looked at earlier. And so for those 3 packages, which are assert, events, and util, we just have to install them. So let's do that now. That's done. Very good. Now the second package, the second category of packages, is packages that we don't really need, so that we can just stub them out to suppress errors. And that was the technique 4a that we looked at in the slides. And those packages are crypto. Crypto, in fact, is only used for the Oracle dialect in Connect.js. It's not needed for Postgres. FS, the file system package, that's only used to load a certificate file if we specify one as part of the connection string. And we don't need to do that because the certificates that are used by Neon can be validated against public root certificates, and they will be by default. And the stream package we don't need because we're not using streaming queries. So we can create a shims folder, and we can create sort of simple empty or stub packages for these. So let's do that now. I'm going to create a shims folder, and just cheat a very little bit. I've already created those shim packages to save a little bit of typing while you're all waiting for me here. So crypto, fs, and stream, and I'm going to copy them into the shims folder. And you'll see that in each case there's just a package.json and a JavaScript file. The package.json has the name and a description, and the JavaScript file is literally just an empty object. So we are just trying to silence any import complaints here because we know that these packages are never going to be used. This is not going to be a problem. And then finally, there are two packages left that make up the third category, and those are packages that we do need to create a simple shim for. And those packages are timers and TTY. Now, one of Connex's dependencies is called tarn, and for some reason tarn imports clear interval from the timers package, even though it uses set interval as an ordinary global. And so to keep everyone happy here, we can create a shim package that just re-exports the clear interval global as a timers package. And I'll copy that one in now. Again, if we look at that, it's a simple package JSON, and the implementation literally just exports the global clear interval as a clear interval object inside the timers package. And then TTY, the final package that we're missing, another one of Connex's dependencies is called colorette, and that's used to print nice colored terminal output. And before it does that, it checks whether it's printing to a terminal rather than some other file or pipe using the TTY package. And so all we need to do here, we can just rig up the relevant function to always return false, to say this is not a TTY. That will not get us in any trouble because it won't be a TTY in the cases that we're thinking about. And so again, here's my simple shim TTY package. Just give it the name and description in package JSON, and then the implementation is simply that single function is a TTY that's called by colorette, and we just return false. Having done all of that, we then need to add all these stub or shim packages to the package JSON file. So if we find the dependencies here, we can see the ones that we already installed on NPM, but we need to add the others that we've copied across. So for crypto, do this, hopefully spelling it right. For FS, we'll do the same. Just two more left. We need to do timers. Again, these are all these local path packages that start with a file protocol. That's timers rather than timer. And lastly, TTY. So I'm going to save that. I think that all looks correct. Having done all of that, then we need to make sure that they get installed. So I come back to the terminal and I type npm install now. And with that done, we should find that this now just works. So let's try npm vercel dev. That runs the esbuild build command, and then should have this work in a browser for us. Okay, I'm going to copy that URL. And now that'll be not found because, of course, what we are looking for is the index file in the API folder. Having a think, and there we go. So we're returning some entries from the employees table. This is a very literary company, so we have 3 writers as our employees here, and so we've made that work. So I hope that's been useful to you. That about wraps it up for today. I wish you luck running in JavaScript packages everywhere, not just in Node, but in browsers, on serverless platforms, and beyond. Thank you.